Hi friends, this is my 8th lecture of Power System series, and in this lecture we are going to study concept of feeder and distributor design. We will understand the concept of feeder and distributor design with the help of three very important questions. So let's begin with first question. First question is, for same power transfer, same material and same length of line, if voltage is increased by n times, then what will happen to the cross section of transmission line? So here power P is constant. So we can write P is equals to Vi cos phi, and it is constant. Now voltage is increased by n times, means initially voltage was V1 and finally it becomes V2. So we can write V2 by V1 is equals to n. Also, we know that current rating of a conductor is directly proportional to the area of cross section. So we can write for constant power V1 I1 cos phi is equals to V2 I2 cos phi. On rearranging this equation, we get V1 upon V2 is equals to I2 upon I1, and we know that current is directly proportional to the area. So we get A2 by A1, and V1 by V2 is 1 upon n, so we can write 1 upon n. So we get A2 is A1 by n, means area is reduced by n times when voltage is increased by n times. Now take this second question. For same power transfer, same material and same length of line, if voltage is increased by n times, keeping losses constant, what will happen to the cross section of transmission line? See, here again power is constant, but here one more term is added, keeping losses constant. So for constant power P is equals to Vi cos phi, we can write V1 upon V2 is equals to I2 upon I1, that is equals to 1 by n. We have already derived this in first question, so we can take it directly from first question. So now the second condition is losses are constant, means I square R is equals to constant. So we can write I1 square into R1 is equals to I2 square into R2. So on rearranging this, we get R1 upon R2 is equals to I2 square upon I1 square. And we know that this current is directly proportional to area and resistance is inversely proportional to area, because R is equals to rho L by A, so resistance is inversely proportional to area. So we can write R1 upon R2 is equals to I2 square upon I1 square, then I2 is directly proportional to A2 and I1 is proportional to A1, so we can write I2 square by I1 square is equals to A2 square by A1 square, and we know that I2 by I1 is equals to 1 by n. Okay, so we get is that this whole term equals to 1 by n square. Now R1 by R2 is equals to 1 by n square, and we know that R1 by R2 is equals to A2 by A1, so we can write A2 by A1 is equals to 1 by n square. So if voltage is increased by n times keeping the losses constant, then in that case area will get reduced by n square time. This concept is utilized in feeder design, and this is because losses are main criteria to design a feeder. Now take this third question. For same power transfer, same material and same length of line, if voltage is increased n times, keeping per unit drop constant, what will happen to the cross sectional area of transmission line? So again power P is constant, means Vi cos phi is constant, so we can directly write the expression from first question. For constant power, V2 by V1 is equals to n and I2 by I1 is equals to 1 by n. But here per unit drop is also constant, means IR upon V is equals to constant. So we can write I1 R1 upon V1 is equals to I2 R2 upon V2, and it gives I2 upon I1 into V1 upon V2, that is equals to R1 upon R2. Here I2 by I1 is equals to 1 by n, so we can put it here, and V1 by V2 is equals to 1 by n. So we simply get R1 by R2 is equals to 1 by n square. Now we know that R is inversely proportional to A, resistance is inversely proportional to area. So we can write R1 upon R2 is equals to A2 by A1, that is equals to 1 by n square. Means area is reduced by n square time. Okay. So this concept is utilized in distributor design because it is main criteria for distributor design. So we can conclude the whole lecture as, see, main function of feeder is to carry maximum power to the consumer. That's why losses are main criteria in feeder design. Why main function of distributor is to provide rated voltage to the consumer. That's why per unit voltage drop is criteria in distributor design. So this is all about this video. I hope you understand this concept. Thank you. Jai Shri Ram.